Hello everyone. Today I'll share with you how to use the for counters, nested for counters, and some examples to illustrate those concepts. Stay tuned. For more videos, make sure to subscribe to the channel and activate the notification bell to be the first one receiving the latest video. So here in this example, I will show you how to use the for counter, and the idea here is to find the factorial of a number. So first, let's start by declaring some variables, and then we'll go from there. And one of the variables is integer. F is the factorial, and we'll initialize it to 1. Here F will save the factorial at the end. The main format of the for counter is by starting using the keyword for, then these parentheses, and then we'll declare a variable that we will use in order to move from one number to the end of the for counter. So here the number of this counter will start from 1. I will repeat from 1 to I is less than or equal to the number that we want to factorial of. So here, let's say the number that we want to find the factorial for is number 4, and so that's why I will do the counter from 1 to 4. And here, next semicolon, look at this, we are using semicolons. I will do the increment, how much this counter will be incremented. So it will be started with I equals 1, and then will be incremented by 1 each round, each iteration. Here, I will use the F that I just declared, and we'll say the new F equals to the old F times I, which is the counter here. Now let's try and test. So I will print this message, factorial of 4 equals to F, which is the final result. So let's start and test this one here. Here is the result. 4, the factorial of 4 is 24. So let's try doing another number. If you want to find the factorial for number 3, so here we'll run it again, and the number of 3 will be 6. So based on this one, for 3, that means 3 factorial means 1 times 2 times 3. So as you can see here, we have some numbers starting from 1 to the destination here, the target, which is 3. So the counter for I is representing these numbers, generating these numbers, and each time we are accumulating the results and save them all together in the F here. Now let's do another example based on what we have achieved so far. So I want now to find this series, the result of this series, where y equals to 1 factorial divided by 1 plus 2 factorial divided by 2 plus 3 factorial divided by 3. So we want to do this equation, this series, and we'll take advantage of the factorial that we just finished, and then we'll divide the factorial by the number here 1. So 1 factorial divided by 1, 2 factorial by 2, and so on. So we'll take advantage of the counters, the for counters, and what we achieved, and here we will improve this code as follows. So first I will declare a variable named y and initialize it to 0 here, and next I will start doing the equation, this one. So here in each term, here in each item, we have two things. We need to generate, to do the factorial and divide them by the number 1. So let's say that here is the factorial, this one is the factorial part. Now each item here needs the factorial. So that's why I will use another for counter, and here I will say j equals from 1 to j less than or equal 3, because we want to do the series of 1, 2, 3 as it's mentioned above. And here the increment will be by 1 as well. Now here, as you can see, we have 2 for counters, and if you have 2 for counters, one is following the other, this is called as a nested for counter, nested one. Now instead of finding the factorial for number 3 as we started with in the previous example, here I will do the factorial for the first term, which is 1, and the second term, which is 2, and the third term, which is 3. So these numbers 1, 2, 3 will be generated by the j counter. The I counter, the purpose of I counter is to find the factorial of each item of the j factorial. So that's why I will say that the I will be equal 1 to j to this one. Now let's get rid of this one. We don't need the factorial anymore. We want just to find the results. So we need the brackets here. We need the brackets to repeat this process for each round of the j counter. So we need to repeat it for this item, and the third item as well. So that's why each round from the j will repeat the process of I will walk from 1 to the current number of j, the current value of j, and finding the factorial. Next, after finding the factorial, we need to accumulate the results and save them in the y variable that we declared. So back to the series, we need the factorial, which already we generated with f in the line above, 14, and dividing them by 1, and the 1 is generated by the j counter, which is here. So in order to accumulate the values, the old plus the new one, we need to do this. Y, the new y equals the old y plus f over j. Good. At the end, when we are done, let's just print the, so here end L. One more thing, we need to reset the factorial each time we are moving to the next term here, as you can see. So here the result is 4. The result of this series is 4, and this is the target. So this is for now, and I hope you learned how to use the nested for counters as we saw here. So each round from the j counter will repeat all the rounds of the I counters, and these are very similar to the watch, your watch. We have the minutes and hours. So each round from the hours needs the 60 minutes to be passed as well. So these are the two things. So the j will represent the hours, and I is similar to the minutes. And thank you, goodbye.